Hello students, so in this video we'll study about critical constants of a real gas and Andrew's isotherm. Myself Dr. Sofia Gupta. Let's start with the critical constants of real gases. Now students, it is a very easy concept. Just listen very carefully. For example, we know that we want to compress a gas, है ना? It should have intermolecular forces of attraction. Like we know that in the ideal gases we have no intermolecular forces of attraction, so ideal gases cannot be compressed. So the critical constants such as critical temperature, critical pressure and critical volume, they are not applicable for the ideal gas. That's why I have written critical constants of a real gas. Now we know that to compress a gas we need high pressure and temperature should be low. Now for example, I want to compress a gas but I am giving a temperature very high, but simultaneously I am also applying a pressure very high. So it is impossible to compress a gas even if I am applying a high pressure, because the temperature is also very high. So this is critical temperature. Critical temperature is like a maximum temperature. It's a maximum temperature of a gas above which the gases will exist as a gas irrespective how much high pressure you are applying. Okay, so if you want to write down, you can write down the critical temperature. It is a maximum temperature above which above above which a gas cannot be liquefied howsoever high pressure is applied. Means you can like howsoever high pressure you can apply, you cannot liquefy a gas. So there is a certain temperature below which the liquefaction of the gases is possible if we are applying high pressure, and above which the liquefaction is not possible. Let me explain you with the help of an example. Like for carbon dioxide, the critical temperature is 31.1 degrees Celsius. This is experimentally determined. Okay. Now if you are giving the temperature greater than 31.1 degrees Celsius and we are applying very high pressure, the gases will not get liquefied. Below the critical temperature, that is below 31.1 degrees Celsius, if I apply high pressure, the gases will get liquefied. Liquefied means it will get converted to liquid. I hope the concept of critical temperature is clear. So Andrew, he was a scientist. He studied the uh, graph for carbon dioxide in order to explain the concept of critical temperature. This is basically a PV graph. Now isotherm means iso is same and therm is temperature. So all the readings are taken in at same temperature of a one graph. Like before we start Andrew's isotherm, I'll explain you. This is a P, this is a V. P stands for pressure in atmosphere and V stands for volume in liter. Okay, so the study were done at constant temperature. This is a one isotherm, let's say at 10 degrees Celsius. Now in one graph we can draw different isotherms. Like we can like at 20 degrees Celsius the study is done, at 5 degrees Celsius the study is done. So in this graph there are four different isotherm. This one graph, basically the students get confused that there is four temperature. No, like you have to understand throughout this graph, throughout this which I have done red highlight, the temperature is 20 degrees Celsius. So this is a first isotherm. This is a second isotherm. This is third at 5 degrees Celsius. This is fourth isotherm. So in a single graph we are having 4 isotherms. ठीक है, this is a concept of isotherm. मतलब during a study the temperature is constant throughout. Now let's proceed to Andrews isotherm. Now it is also a PV graph. Okay, this we are doing for carbon dioxide, different temperatures of carbon dioxide. We know that critical temperature is 31.1 degree Celsius. This is the temperature at 31.1 degree Celsius. This is temperature less than 31 degree Celsius. Let's say 15.1 degree Celsius. This is 10 degree Celsius, and above this they are of higher temperature like 40 degree Celsius, 50 degree Celsius. Okay, now according to our definition, critical temperature is that temperature above which a gas cannot be liquefied howsoever high pressure is applied. So the temperature above 31 degree Celsius, that is 40 and 50, they exist only as gases. No liquefaction is possible. ठीक है, now you can draw a hump like this. This is critical temperature. ठीक है, अब we will let's say we'll study this graph at 10 degrees Celsius. Let's divide into 3 parts. This first part, then BC is second part, CD is third part. Now let's study the curve AB. As I move from A to B, like as I move from A to B, the pressure increases, volume decreases. Here the gases are existing in a gaseous phase. ठीक है, now as I increase the pressure, the volume of the gas decreases, so the liquefaction starts over this curve. Now at the point B, some gas got converted into liquid and some is still in a gaseous mode. Now for the curve BC, now for very low increase in pressure, the volume drastically decreases. So BC, it represent that the gaseous phase and the liquid phase of a molecule is in equilibrium with each other. ठीक है, at the point C, all the gas got converted into liquid, and from C to D, as we increase the pressure, the volume will further decrease, and this represent liquid phase. ठीक है, here the liquid and gases, they are in equilibrium. Now this graph basically shows that how a molecule in a gaseous phase converts into liquid phase. Firstly it was gas. As I increase the pressure, see, firstly the pressure was this much, then I increased the pressure to here. So as I increase the pressure, the volume decreases, liquefaction starts. Here the liquid and gases, they are in equilibrium. Further, when I increase the pressure, it get converted to liquid. So main moral of this Andrews isotherm is that above 31.1 degree Celsius, the molecule exists in only gaseous phase, even if you apply very high pressure, and below 31.1 degree Celsius, as the pressure increases, the gas will get converted to liquid, and as the temperature increases, like from 10 degree Celsius to 15.1 degree Celsius, this horizontal portion becomes narrow, and finally at critical temperature this portion becomes equal to 0. ठीक है, I hope you understood this Andrews isotherm. Now we will do some basic definition which is clear already, but just for a revision. What is critical temperature? It's a maximum temperature above which gases cannot be liquefied howsoever high pressure is applied. Okay, so you have to learn its formula. It is 8A upon 27 RB, where 8 and B are van der Waals constants and R is a gas constant. Its value is this per Kelvin per mole. Okay, or you can use 8.314 joule per Kelvin per mole. Now the second definition is critical pressure. So what is critical pressure? Corresponding to this critical temperature you will get critical pressure. It is 72.9 atmosphere for carbon dioxide. Now what is critical pressure? It is the pressure at critical temperature at which the gases are getting liquefied, and its formula is A upon 27 B square. Okay, similarly third is critical volume. It is the volume occupied by the gas at critical temperature and critical pressure. So critical volume's value is 3B. Okay, so based on this the numericals will come. I'll give you one example. Like they can give you the value of critical temperature, critical pressure, let's say 20 degrees Celsius or 2 atmosphere. They will ask you evaluate A and B. Clear? So we know that critical temperature is 8A upon 27 RB. Critical pressure is A upon 27 B square. Okay, now this is in degree Celsius. Firstly convert into Kelvin by adding 273, so it is 293 Kelvin. Okay, so this will become 293 Kelvin is equal to 8A upon 27 RB. This is 2 is equal to A upon 27 B square. Okay, now when we divide 1 and 2, 293 divided by 2, this A से A cancel and B 1B 27 27, you will get 8 upon R B. ठीक है, R you will put 0.0821, this you will put, you will get the one value of B. So that value you can put either in equation 1 and or in equation 2 and you will get the value of A. I hope this topic of critical constant is clear to you. Students, if you are having any doubt, so you can pin down your doubts in the comment section. Thank you.